Now let us look at how the equations of different types of chords of a circle can be written. So I hope you all remember what a chord is for a circle. Any line that intersects the circle at two different points is known as the chord of that circle. Now what is a chord of contact? Let us assume this is our circle and there is a point that is outside the circle. And from this point, I draw two tangents in this way. Now these tangents are of course intersecting the circle at one single point. Now if I join these 2 points together, this basically becomes one of my chords, and this chord is known as my chord of contact. This is nothing but my chord of contact. If this point has been given to me, this is x1 comma y1. Now how can I write the equation of this chord of contact? It is written as t is equals to 0. I hope you all remember I had taught you about how we can write down the t for a circle. X square used to convert into x1, y square used to convert into y1, x used to convert itself into x plus x1 by 2, y used to convert itself into y plus y1 by 2. So similarly, once you've done all that, you've gotten the value of t, you equate it to 0. That is the equation of this chord of contact. Now you must be thinking we haven't studied anything about the tangents, we haven't studied anything about the normals that exist between the tangents and circle. Now of course those things have been removed from the syllabus of JEE Mains. The only thing is chords, only a few portion of the chords are included in the syllabus, and this chord of contact, of course, remembering this formula of chord of contact, t is equals to 0, is in the syllabus. That is why we are studying this. So now I just want to remind you that whenever you are writing the equation of t, let's say this is our equation of circle, plus 2fy plus c is equals to 0. This was my equation of circle. So my s, this portion would become my s, and so how can I write down the t for this equation? It would become x1 plus y1 plus 2g x plus x1 by 2 plus 2f y plus y1 by 2 plus c. This would become my t, and now if I equate this entire equation to 0, this would become my equation of this chord of contact. Now the point that you must note here is that x1 y1 are the point that is the external point. This point of course lies outside the circle. So let's say if I was to find out s1 for this point, it would of course be greater than 0 for this point because it lies outside the circle. So you must remember this thing, t is equals to 0. Now there is one more thing that you must remember about the chord of contact. From here to here, of course, this is my length of chord of contact. You can simply just remember the formula of finding out the length of chord of contact, and it is written as 2RL by root under L square plus R square. Now of course you must be thinking what my R here is and what my L here is. So R is nothing but my radius of the circle, or you can connect it this way as well, radius of the circle, and L is my length of this tangent. From this point to this point, this length here is my capital L. So if by using this formula we would get the length of chord of contact. Of course you can prove it by yourself. You can divide this into two exact equal halves, find out the length of this half using this right angle triangle. If this length is known to you, L, you can find out the midpoint, and of course it is a very lengthy process. So simply I would recommend you all to remember this formula, which is finding out the length of chord of contact, which is 2RL by root under R square plus L square. You must remember that L here is the length of the tangent. Now how can we find out the length of the tangent? Of course that must be a question. We will look into that in the further slides. Yes, so exactly the same things have been mentioned. The coordinates of the external point has been provided to you. The circle has been provided to you. The equation of chord of contact is written as t is equals to 0, and it is given in this format. Now let me write down the formula here as well so that you remember the length of chord of contact. This is 2RL by root under R square plus L square. Now let us assume, now let us try to find out equation of any chord that has been provided to us. Let's say this is a circle, any chord has been given to us and the midpoint of the chord is given. Now this is the midpoint of the chord, x1 comma y1. So how can we write down the equation of this chord? The equation is written as t is equals to s1. Now I hope you all remember how we can write down t. T is nothing but this value up till here. This is my t. And what is my s1? S1 is of course nothing but me putting the values of x1, y1 in the equation of the circle. So let's say if my equation of circle was x square plus y square plus 2gx plus 2fy plus c is equals to 0, then my s1 would be nothing but satisfying x1 and y1 in that equation. So of course, since m is a point which lies inside the circle, it is the midpoint of the chord, so s1 here would always be less than 0. I hope you all are understanding this point. And if I was to find out the length of this chord, it is simply given as root under s1. Root s1, length of chord. So we found out the equation of the chord. We know how to find out the length of the chord as well. We know what chord of contact is, and we know how we can find out the length of the chord of contact as well. So again, these are important things that you must remember. Now let us look at one more way how you can find out chords, or how questions can be asked related to chord. Let's say two circles have been given to you and they intersect each other. Let's say this is my circle S1, this is my circle S2, and these two circles are intersecting each other this way. Now they ask us to find out the chord that exists for both the circles, like the chord that passes through the points of intersection of these two circles. So of course this would be my chord. So how can I write down the equation of this chord? The equation of this chord is simply given as s1 minus s2 is equals to 0 using this formula. Now this formula of course works only when you have been provided circles when they are intersecting. Let's say if the circles were non-intersecting, and if you apply this formula, then you would have gotten a line that would exist between these two circles. So of course that is not what we are looking for here. So again, I'm repeating, if there are two circles given to you and they are intersecting at two different points, and they have asked you to find out the equation of chord of these two circles that pass through the intersection of these two circles, the equation is given as s1 minus s2 is equals to 0. Simply, I hope you all can understand that x square and y square terms would be cancelled from this. And if once they are cancelled out, you would be remained with only the single degree of x and single degree of y, and that is how the equation of any straight line is written. So that is how you find out the equation of chord. Let us look at this question to clear our concepts a little more. If two parallel chords of a circle having diameter 4 units, that means our radius has been given to us, which is 2, lie on opposite sides of the center. So this is my circle, this is my center. One chord is here and the other chord is here. Of course, these two are parallel to each other. These two chords are parallel to each other, and they subtend angles cos inverse 1 by 7 and sec inverse 7 at the center. That means the angle that they are subtending, let's say this one is theta, and the angle this chord is subtending, let's say this is phi. So there are two angles. So they've given us information about these two angles. Phi is nothing but cos inverse 1 by 7 and theta is nothing but sec inverse 7. Now we have to find out the distance between these two chords. That means the perpendicular distance basically. So how can you proceed for this question? Let me draw it once again here. The center has been given to you. So if let's say if I'm able to find out this perpendicular distance and I'm able to find out this perpendicular distance, wouldn't I be able to find out the distance between these two lines? So our distance between these two lines is nothing but finding out the perpendicular of these two triangles. Let's say I drop a perpendicular here, I drop a perpendicular here. So basically I need to find out the length of this line, these two lines, and their sum would become my answer. So let us first find out what are theta and phi are in terms of cos theta and cos phi. So if I was to do this, convert this inverse trigonometric function into a normal trigonometric function, this would become cos phi is equals to 1 by 7, and this one would become sec theta is equals to 7. So if I convert this sec theta into cos theta, this would be nothing but 1 by 7. So that means our theta and phi both are equal. So cos theta is also equal to 1 by 7 and cos phi is also equal to 1 by 7. That means my theta is equal to phi. So of course it becomes easier for us now. Now we can just find out the length of one of the perpendiculars, and we can simply multiply it by 2 to get the complete distance between the chords. Let us do that here. So this is my circle, this is my center. This is my circle, here is my center, and this is the angle that it is subtending. So if I of course drop a perpendicular here, this length here is my radius, which is 2. Now I hope you all remember we had studied this, that whenever there is a chord and if I drop a perpendicular from the center of the circle on that chord, it divides that chord into 2 equal halves. That means this portion is equal to this one. So now from here, what else can we see? The entire cos theta, this entire theta, we know about that. Cos theta is equal to 1 by 7. Now let's say, if since this is a perpendicular and it is dividing these two lines in this line into 2 equal halves, that means it must be dividing this angle as well into 2 equal halves. That means this would be theta by 2 and this would also become theta by 2. So now from here, what can I write down? Let's say this distance here is my, let's say if I write this down as A, and this is my distance that I need to find out, this is D. So what can I write down about cos phi theta by 2 now from here? Cos theta by 2 would be nothing but base by hypotenuse. And what is my base for this? D by hypotenuse, which is 2. So I know the value of cos theta by 2. I know the value of cos theta. So wouldn't I be able to find out D? Of course, we have to use the formula that we had studied in trigonometric functions, where cos 2 theta used to be equal to 2 cos square theta minus 1. So cos 2 theta used to be 2 cos square theta minus 1. From here, of course, my 2 theta is nothing but, I'm considering it to be theta, and my theta is nothing but theta by 2. So from here, can I write it down as in this format? Cos theta is equal to 2 cos square theta by 2 minus 1. I hope you are understanding this, how I wrote this equation. Now simply let's just substitute the values. Cos theta is 1 by 7. 2 cos square theta by 2 is d by 2 whole square minus 1. Now let us solve this equation here. What do we get? Taking 1 on the other side, we get 8 by 7. This would be equal to d square by 2. And from here we get d to be equal to 4 by root 7. So I've gotten the distance of one of the sides. Now this is not my answer, of course. I've gotten the length of one of the sides. This is my d, and d is equal to 4 by root 7. Of course, theta is equal to 5, so the length of d would also be same for this side as well. 4 by root 7. So if I add these two, I would get the distance between the two parallel chords. So of course my answer simply becomes 2 times of D, which is my 2 into 4 by root 7, which is 8 by root 7. So this is my answer. Again, a question that was asked in one of the previous year JEE Mains papers. So a good question, of course. You had to find out the distance between these two chords. The catch here was that if you could have found out that phi and theta both are equal, then of course the calculation of this question would have become very much easier for you. Now let us look at a few more other properties about chords and their equations. Let's say a circle has been given to you. Again, there is a point outside, which is my P point, and I draw two tangents here. And I draw two tangents from this point, P. And I name these intersection points A and B. This is my chord of contact. So I hope you all can see that there is a triangle being formed here, right? Now simply let us assume if they were asking us to find out the area of this triangle APB. So simply the formula is RL cube by R square plus L square, where R is nothing but my radius and L is nothing but my length of this tangent. And now I will give you one formula that you must remember. Of course, we aren't going to get into the deep study of tangent, so this is just an formula that you must remember. L, which is nothing but my length of tangent from an external point. This is given as S1. I hope you all remember the length of chord used to be root under S1. There S1, the point that we used to consider was the midpoint of that chord. However, here length of the tangent, that means from point A to P, this is AP. This length is known as length of tangent, and this is my S1. Here S1, we are putting the point P. We are considering that my external point has been provided to me. So this length is simply given as S1. So you can find out, of course, the area. You can find out tan of this angle APB. That means if I consider this angle to be theta, my tan theta becomes 2RL by R square, by L square minus R square. Now once you found out theta in the entire equation, you can of course divide it by joining it with the center, and it would divide this two halves into equal angles. So this would become theta by 2, this would become theta by 2, of course. Then you can find out anything that the question asks you. So again, an important things that you must remember: the length of tangent from an external point, it is given by S1, where the external point is my x1 and y1, which has been provided to me. The area of this triangle APB is given by this formula, and the tan theta, which is my APB, angle APB tan theta, is given by 2RL by L square minus R square. Now let us talk about, so that was all about chords and their equation, a few things we studied about tangents as well. Now let us look at mirror image of a circle in a line. Of course, this is nothing different from what we studied in straight line. In straight line, I hope you all remember we had studied a formula that used to give us the mirror image of a point on a line. So let's say if a straight line has been given to you, this is my center, this is my circle. So of course my mirror image would be somewhat like this. Of course the radius of my original circle and my mirror image would be same. This is my S dash, this is my S. The radius would be same. The center would of course be known to you, x1 comma y1, and from here you can find out our x dash comma y1 dash. Of course this distance, let's say this is D, this distance would also be D, since this is a mirror image on this line. And I hope you all remember the formula that we had studied in straight line, which used to be x minus x1 by a is equals to y minus y1 is equals to minus 2, and then we used to put the point in the equation of this line divided by a square plus b square, which used to be the general equation of line. So again, the same concepts that we had studied in straight line. To find out the mirror image of a circle and the mirror equation of that circle, simply you just need to find out first the center. Once you found out the center, you know the radius is going to be same. You can simply use the standard equation that we had studied in the first lecture in the circle to find out the equation of this mirror image as well. So there's nothing a new concept that we have studied here. Now we will be looking into family of circles and a few more other topics.